So, we are at the last phase of this course, space geometry, development of surfaces. Now, outline what is development of surface, method of constructions and alternative strategy. Now, use of developments in manufacturing industry, normal size pattern of a surface of an object as required. For example, in sheet metal work, a sheet needs to be laid out, true edges, surfaces are marked, sheet is cut and rolled, folded and formed to make the complete object. The complete surface laid out in a plane is called development of the surface. Remember, the complete surface laid out on a plane is called development of the surface. All surfaces are not developed, that is raft or double curved surfaces or a ball, etc. Then development requires concepts such as finding true length of edges, lines, true shape of plane faces of an object. Now, here the concept of true length will come into picture, because we are taking line as a true length. If there is one edge, then we have to convert into true length, and if there is a plane, then we will have to convert to true shape. True surface of different components of the objects are joined at common edges to form developed surface. What will be the development of right cylinder? A very simple question. What will be the development of a right cylinder? A rectangle of dimension L into pi d, a rectangle of dimension of L length phi d is your perimeter. What will be the development of right circular cone? Circular sector radius is equal to slant height, arc length, circumference of your base. Now, look at these objects. I cut it. Now, look at how your development of the surface. There is a circular surface or cylinder. I put it in a surface because the cylinder has to be prepared by means of a metal sheet. The cylinder has to be prepared. What is your next step? This metal sheet exact dimension you have to cut it. That means, what is exactly its dimensions in length as well as in diameter directions. This is your length and this is your diameter directions. That means, I will open it, this cylinder, and roll it over a plane sheet. Once you roll it, how it looks? It looks in this way, in this way, in this way. So, that means, this is the metal sheet. Once you cut it, then you can roll it and you can form in the form of your cylinder. Similarly, for other surfaces also. Then look at here prism, look at here, the prism has been folded or developed, the surface has been opened up. How this has been opened up? This is your developed surface of the prism. Similarly, cylinder, this is the developed surface of the cylinder. What are these? These are at the top, this is at the bottom, it has to be packed from both the ends. Then pyramid, look at here, opened up, roll around, then opened up, and if I come back here, it is opened up. Here this surface, this face has been opened up as this surface, then opened up, how it looks. Then come to your cone, cone is looks like this. Then frustum of a pyramid, how it looks. Then now go to constructions. Development of surfaces, how do you construct it? True length of a line can be found by number 1 auxiliary view method, number 2 method of rotations, number 3 true length diagram. Then method 2, 3 are used extensively for development of surface. Method 2 and 3, method of rotation and true length diagram has been extensively used for development of surface. Now look at here, there is a line in top view, this is in top view and this is in front view. Now, this line ABH and CF, now this is your true length of line AB, true length diagram. Now, getting the true lengths, look at here, getting the true length, how you are going to get it? This is a cone, there is axis, then this is your horizontal, that means in the top view how it looks, top view how it looks circle with a dot, then frontal. If I look at this true length axis, then it has been rotated, path of revolution, it will start from here to here, then this is your path of revolutions, then join it, YR has been marked, then measure the theta h, then here YF will be there in the front view, then this will be rotated, this will be rotated, then you get it YHR in the front view, then project it back, sorry YHR in the top view, then project it back in the front view, then project it back, and this is your YFR. So, this is your theta h and this line is your true length. If the true altitude and base of a line are known, the hypotenuse is the true length of the line, that is true. Then let us start with example, development of surfaces. First is your rectangular pyramid, how it looks rectangular pyramid in color. Now, you can name it A, B, C, D, and at the top you can name it as a O, this is your O. Then this is how your top view looks like. The moment I look from the top, what will happen, everything will be merged, only A, B, C, D will be looks like. This is your A, B, C, D, then O will be at the bottom. Then front view, how it looks your front view, this is your front view, O, B, C, A, D, F, this is your front view. Notice that side A, B, B, C, C, D and D, A are seen in true length in the top view. A, B, B, C, A, D, C, D are in true length. Why? These are parallel to one of the axis, one of the, that means these are in true length in the top view. Now, true length of other sides of the pyramid, that means OA, OB, OC and OD, it has to be evaluated. Now, let us start with this O1. So, how to find it out OA true length? The basic thing is, you taking as O as a center, OA as radius, you rotate it till OA is parallel to your hinge line, then this has to be projected back in the front view and measure OA here, this will be your true length. Once it has been rotated, this line will be parallel to your hinge line, then project it back, then project it back, then join AR, join it. So, this is your true length of line OA. Now, considering O as this, then one found mark of true length of developed surface, then join it, find it out your OA1, this is your true length. Similarly, for other lines you can find it out, that is your, how you are going to get it, AB. AB in the front view, what happened, AB in the front view, it is parallel to your hinge line, that means in the opposite view of the AB, this is in true length. So, measure the AB in the true length. From considering AB, mark an arc here, then from OB, OB1 mark an arc. So, you have to find it out OB1 true length. How to get OB1 true length? From here you rotate it here parallel, then project it back, then from here to here you join, here to here you join. So, this will be your true length. That means, from OB you take the true length, mark arc A1 and B1, this is your measured true length, mark arc, and where is your intersection, mark that point. So, in this way you start developing one by one, B1 C1, O1 C1, then C1 D1, O1 D1, then O1 A1. So, we started with O1 A1, we end with O1 A1. This is your development of this surface, particularly a rectangular pyramid. A simple example for understanding. Oblique rectangular pyramid, look at how the oblique rectangular pyramid looks like. 1, 2, 3, 4, then A. This is your top view, then this is your front view, name whatever name you have given, as per that you give the name. Then from there project it back, then your first part is your, you have to take A4 as a true length, find it out one by one true lengths. If you look at here, what happened? 4A rotate it back and project back, then join. Similarly 1 4 rotate it back, project back to join. That means these lines are parallel to hinge line, that means this is in true length. This is your parallel to one of the profile plane, that means this is in true length. Only true length of the line where you are going to find it out, 1A, 2A, 3A, A4. That means every time you rotate it considering as one of the radius or center on one of the radius, then project it back in the opposite view and measure the true length. So, this is your developed surface of the pyramid. It is very easy if you go by step by step. Then come to the next, frustum of a pyramid. Look at here, a pyramid is there, it has been cut, then frustum of the pyramid, this part will be there, this part will not be there, it has been extended to look like a pyramid, then project it back, then take it, then draw the lines, all the lines, true lengths you have to find it out. That means frustum of a pyramid, there is a inner surface, this is your inner surface, there is a outer surface. For outer surface you name it 1, 2, 3, 4, 5, 6, here it is 1, 2, 3, 4, 5, 6, and this is your inner surface, this inner surface you find it out true length, and this is what is your development of the surface, particularly frustum of a pyramid. Then come to the next, frustum of a cone. Look at a cone, there is a cone and this cone has been cut. At the top is, this is a cone, one part has been cut, then this is there is a cone, then rotated back, then how it looks like? One is your outer surface, other is your inner surface. So, this represent your inner surface, this represent your outer surface. This is how your development of the surface, how if you open it up, how it looks. Then development of surface, truncated prism. These are the example one by one I am explaining, so that it will be easy for you in examinations. How the truncated prism, the prism has been cut in an inclined plane, so it become a truncated. Now what will happen? This is your truncated prism, so you name at the base A, B, C, D, then where it has been truncated you name it 1, 2, 3, 4, 5, 6, then horizontal and frontal, this is your prism base part, project it back, how it looks in the front view how it looks, this is your base A, B, C, D, E, F, then it has been truncated, it looks like 1, 2, 3, 4, 5, 6, then what will happen? You write it 1A, 2B, 3C, 4D, 5P, this is how truncated prism. If I open it, how it looks like? Then lay out the base first, true length available in top view, definitely true length available in the top view. So, this will be in the true length, this will be in the true length, then lay it down considering point 1, 0.26 lay it down, 0.35 lay it down, 0.4 lay it down, then project it back one by one, whatever you are getting your true length, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 7, 6, 7 or 6, 1, it started with 1, 6, 1 will be there. So, only thing that this is inclined, this part true length has to be found out, otherwise the base, this is your parallel or touching to your hinge or parallel to your hinge, that is in the true length. So, this is what is your development A, B, C, D. Need to draw true surface of oblique surface, true surface of oblique surface. This is your oblique surface, you have to draw true shape of the oblique surface and need auxiliary. You need to have one auxiliary plane. Then in this auxiliary plane, because this surface you have to find it out, this is an inclined surface or oblique surface, you need to have true shape. Then you have to either by method of rotations or by means of auxiliary plane, you have to find it out what is your true shape. Then auxiliary plane has been taken, then projected back, mark it, then the distance will be, because it is touching here, you are taking auxiliary plane, this to this will be same, then this from here to here distance in the opposite view, the distance will be same. Then take into considerations, this is your part of your true shape of the oblique surface, then draw the true shape of the oblique surface, how it looks. This is about your prism and this is your oblique surface true shape, how it looks. This is what your development of the surface of truncated prism. Next come to truncated cylinder. Truncated cylinder, look at, there is a cylinder pipe going on, it has been cut it here, truncated. So, what happened at the base, name it, it has been started 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, at the truncated face also you name it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then draw the front view, draw the top view, in the top view you name it 1 to 12, then draw the front view, you name it at the base 1 to 12 and at the top also 1 to 12, lay out the base, then vertical true lengths. The base has been laid out, see it has been laid out, because the base is in your true length. So, then how it looks? It looks like this. This is your truncated shape or may be development shape. Basic development of surface, that means true length diagrams are required, development of rectangular pyramid, development of truncated prism we have covered, then development of surface truncated cone. This is your truncated cone, both the sides, truncated cone not only at the base, one point also it has been truncated, the dimensions are given, if you look at here, this is a cone, in this cone base has been truncated, top also has been truncated, then this is a cone, front view you draw it, then top view you draw it. What happened? Once you draw the front view considering base, draw the circle, and considering truncated part, draw the circle, then considering this, draw the circle. Then what happened? Make it into 12 equal parts, number of parts should be equal from both inner side, one is your inner face as well as other is your outer face. You can name it 1, 2, 3, 4, 5, 6, 11, 12, 1 prime, 2 prime, then 12 prime. H is your horizontal plane. Then similarly, outer, inner, then also inner also you name it. Inner has been named it A, B, C, D, E, F, G, H, so that there will not be any confusion. Then project it back one by one you project it back. Project it back to your base surface, then same base surface, once I project it back to your base surface, where it cut here truncated part, that has to be named, where it cut it your truncated part, then find it out your true length, one by one you proceed it. This is your outer surface, then come to your inner surface. this is how your inner surface looks like. Then come to this is your inner surface, means this and this is your outer, this one is your outer. Now we have to do this one, that means where it cut it here, this surface has to be truncated back. If you look at here, now this surface is what? O6 is inclined. So, it has to be make by method of rotation to parallel to a hinge line, so that true length will come into picture. So, this is your 6 has been come here, O6 will become here, you joining here. So, mark it O6, O7, then similarly you mark it O5, mark it O3, O2, O1, O12, O11, then you finish it up. This is your, this surface is nothing but this surface, as well as this surface is nothing but we are looking at this surface. This is how it looks, your development of surface. Then there is oblique cone, development of surface oblique cone. Generators are different lengths. Then what happen in this case? Which of the generator is seen in true length? O to 10 in front view begin development by laying of O to 10. O10 is parallel in the top view to your hinge line, that means O10 in the front view it is in true length. So, considering O10 you start laying off, because in the beginning you should have one true length, then only you can start beginning it. Then in fact no other generator in the true length except OC. Use true length diagram to find all true lengths. Note that if true altitude and base of line are known, the hypotenuse is the true length of the line. For line O9, see the altitude and base and get the true length. Look at here, I am going O9, see the altitude and base, this and this if I know, so obviously this will be in true length. That is what I am doing one by one. O9, O7, O5, O3, O1 and OC. Then these are all your, from here to here, these are all your true lengths. Then lay it down. How it looks? It looks at true length, one half of your developed surface, only one half. Then rest, once you know the one half, rest half is a mirror image, you can go it. I will stop it here. So, next class I will go complicated one for transition surface. Transition surface means bottom is circular, top is rectangular. Suppose bottom face is, this is your circular, top is a rectangular. How surface has been transitions occurs between bottom and top, this we are going to discuss in the next class. Thank you.